Hello there. So today we are going to solve a LeetCode problem, longest valid parenthesis. So the problem statement says given a string containing the characters of brackets or parentheses, and we have to find the length of the longest valid parenthesis. So given an example is over here. So this is a given string. We have to find the longest valid parenthesis. So here the longest valid parenthesis would be this, because it has an opening bracket and followed by its closing bracket. So the length would be 2, which would be our answer. So in this case the longest valid parenthesis would be okay. So here we go. The longest valid parenthesis would be 4, and if the string is 0, we know the answer is 0. So to get the intuition of a problem, first of all, if it's an parenthesis problem, we should, the first thing that should come into our mind is an stack. Yes, right. So what is an stack? Stack is an LeetCode structure, or which is based on the LeetCode structure, that is last in first out. So let me what is the best example of this last in first out? Like if we draw the lines somewhat like this. Okay, the line drawn the line drawn at the last will be erased first when we hit the undo button, like this and this. As you can see, this follows the last in first out structure, that is the line drawn at last is going to be erased first. So now let's jump into the problem. So we have to find a valid parenthesis, longest valid parenthesis. So here, on seeing this, the longest valid parenthesis would be this, or we just would be this one. So what could be your solution? Let's discuss. If there is a stack, we will make an stack and we will keep an array. So an array will contain two values, that is if I and or C. Here C will indicate completed or clear, or I will indicate incomplete. Okay, so it will contain in either I or either C. So how our algorithm is going to work is let me just erase this. So first of all, let us think that if we are over here, that is if we are iterating from the first index. Now if we encounter a opening bracket, so then we are going to fill in the array with I, that is it is still incomplete, and we are going to fill the stack with the index of the I, of the latest I. Now then we are going to increment the I over here, that is we are going to increment the table, and we can again see an opening bracket, then we can make an I over here, and then we are going to add it into the stack, that is index new index. Now we are over here. So now we can see we have a closing bracket. Now if we encounter a closing bracket, then we are going to pop an element from the stack. We are going to maintain a variable called popped will be, we are going to pop an element from the stack, that is we are going to pop 1. Now if like 1 is popped, and we are going to replace the I at the 1 as C. So let me delete this. Now we are going to replace the index of pop with C. So we can have a C. So now we are going to the iterator will go move forward, or simply delete that. Now we are over here. Now we can see we have again encountered a closing bracket. Then we are going to pop another element from the stack, and the popped will be now 0. Now we are going to replace the element at popped with C. That is, this I would be replaced with C. In the same way, now we are going to increment this array or this iterator. Now we have encountered a closing bracket. Then what we are going to do is just simply look into the stack, and if it's our stack is empty, we are going to mark as I. If the stack is empty, then we are going to add also a value I. Now after the iteration, now we have to count the longest continuous C's in the array. So that would be an easy part. So let us just code this one. First of all, we are going to make a class of stack which will have certain properties. First self dot stk would be an array. We are going to push an element with self, and in data self dot stk dot append data. Now for popping an element, def pop self. Now first of all, we are going to see if it has capital, if we can pop the element. That is, if self dot stack, then we have to return self dot stack result dot stack dot pop. So we have pop, else we have to return none. And we can also define a function is empty, which will return true if it is an empty, else false. That is, return false if self dot stack else true. So this is in short form of returning in a single line. Or if so, it says that if there is an element in a stack, then we have to return false, else we have to return true. So our stack class is defined, and so we should now begin our coding with our longest valid parenthesis. So we have to first make an array and an stack object, stack stack easy for an stack object. Now we are going to create in the given string in s and see if I is equal closing bracket. This auto completes an answer. Then we are going to append into answer what we are going to append, that is I, that is which will indicate incomplete. and we will push into the stack the length that is at the current position in which we have appended at I. So length of ARR minus 1, and else what are we going to do? And we are going to see if our stack is empty or not. If it's an empty, then we are going to just add an I, that ARR dot append I, and we will just continue. Else if it's not an empty, then we are going to pop an element from the stack dot pop, and we are going to make the popped element or index, or the element at index popped as C or cleared. So that should work. Okay, if it is in this and this. Okay, now what we are going to do is just simply, now we are done with the string of parentheses. Now what we have to do is just count the continuous C in an array. So we are going to return 2 into count. I am going to explain why I am making this 2 into count in later. So we are going to make a function count, which is going to take an argument, which is going to take an array as an argument, and we are going to answer 0 I is equal to 0 and 0 is equal to 0, and while I is less than length of ARR and J length of ARR, we are going to perform, that is we are saying the longest longest string or the longest substring which have only C's in it, that is completed one or the cleared one. If ARR of J is not equal to C, that is it is not equal to C, then we are going to answer is equal to max of J minus I comma answer. That should be self-explanatory. J plus by equal to 1 and I should be equal to J. Else we are going to do J is plus by equal to 1, and what if we have the C's at the end, then we are going to return maximum of J minus I comma answer. So what this count function does, so what does this count function works is given an string of C's and I, we need to count the number of longest continuous C's. So we are going to make a sliding window problem. It is just, we are going to start from anywhere, and we have to just keep the longest in an answer. So after return, one more thing, that is this function would return 3, that is the longest continuous C's is in this array would be, in this string would be C. So here answer would here it will be written 3. Now we have to make it into 2 because the complete parenthesis consists of and two elements, that is closing and opening one. So we have to make it into 2. So let's just hope the our code works. Our code should work. Okay, there's an error. Okay, I can see over here typo error. Okay, sorry, my mistake. If it didn't, please try and if you can and subscribe to video. Okay, the code is accepted. Now let's, what is stuff? Okay, let's try to submit it. So there's a success. So our code works. I hope you get the solution. If not, please tell me where I can improve. Thank you very much. Pause recording.